So in part 3 of section 3.1, we address what the set of input values is. So this is actually how to find the domain, that set of input values. So how can we determine the domain when given an equation? It's easy if we've got a picture, but how do we do it if we've got an equation? So the first you have to do is classify the equation as one of the following 3 types. So the 3 types are a radical equation, that would be involving that symbol, and we're specifically talking about an even root here. There are no restriction on odd roots, but there are restrictions on even roots. We can't take the square root of an even number. So there are restrictions there. Anything that has a rational equation, and what that specifically means is x is in the denominator, x in the denominator of a fraction. So fractions themselves are okay. It's when x is in the denominator of the fraction that you have issues. And then finally, the anything else category. And these are our 3 categories. And we're going to come in and take a look at each of these individually, but essentially these are 3 different types of functions. How do we go about inputting or determining what the set of input values is? It's really that, that's else. So the order we do them in doesn't matter. I just start off with the one that I think is easiest for you to comprehend, and that's case 1. We're going to talk about radical functions. So case 1, an equation containing a radical or an even. So radical. Specifically, we're going to look at f of x is equal to the square root of x plus 3. Now, I want to determine the domain. Now, what that means is I'm asking you, what numbers can I plug in for x and get a real output? So numbers going in, giving numbers coming out. Well, if we plug in a 1 plus 3, that's 4, square root of 4 is 2, so 1 works. Does 0 work? Well, yeah, 0 plus 3 is the square root of 3. It's not a nice number. It's a decimal if you think about it that way, but it still works. Can I plug in negative 3? Okay. So if we plug in a negative 3, so f of negative 3, that would be the square root of negative 3 plus 3. Well, that's the square root of 0, and that still works because that's equal to 0. So that's fine. But can I use a negative 4? So that would be the square root of negative 4 plus 3. That's the square root of negative 1. That definitely does not work because I can't take the square root of a negative 1 in the real number system. So we definitely have some numbers we can't use. We're going to recognize that they're mostly negative numbers. So what we have to avoid is taking the square root of a negative number. So how are we going to ensure that that works? Right? We need some mechanism to help us avoid those negative numbers. So what I want you to do is I want you to take whatever is on the inside and set it greater than or equal to 0. Why equal to 0? Because we saw it's okay to have a 0 in that radical, right? And then you need things that are positive. That's why we're going greater than. So for us, we're going to take x plus 3. We're going to set it greater than or equal to 0, and we just need to solve that. So x is greater than or equal to negative 3. So here's that negative 3. We're going to use a closed circle going to the right. So because I want interval notation in my classroom, that domain is going to start at negative 3 with a bracket and go off towards infinity. And that's how you go about finding the domain. Anytime you have an even root, this is the process to use. Well, that's pretty straightforward. Let's do one more. Of this case. So part B on that one says, okay, what if we have h of x is equal to the square root of 1 minus 3x. Wait a minute, we have a couple of problems here. Let's make sure we address them. All of a sudden, that's not an f, that's an h. Does it matter? No, not at all. You can use any letter of the alphabet you want. You can use uppercase, you can use lowercase. Still, it's not going to matter. What does matter is that the variable inside the parentheses following that is the variable on the right hand side. So this is a function written in terms of x. So not an issue. We're still going to do the same thing. It's an even root. We're going to come in and take 1 minus 3x, set it greater than or equal to 0. And we'll solve that. So negative 3x is greater than or equal to negative 1. Dividing by the negative 3, remembering to flip the inequality, is going to give me a 1/3. So what we're saying in this case is here's our 1/3. It's a closed circle, but we're going to go to the left. So we have negative infinity to 1/3. Now, if it were an odd root, we'll talk about that here in a minute, but odd roots, you don't do this process. It's a different process for odd roots. This is just even roots. Okay, what about case 2? What happens if we go to put x in the denominator? So these are the rational functions. So case 2, an equation involving an x in the denominator. So this is rational functions. And notice the vocabulary that's coming in, right? Radical functions, rational functions, but rational simply tells us that x is in the denominator. So as an example, we're going to do g of x is equal to 3 over x minus 4. So for the first time, we see that x in the denominator, right? And we can still evaluate this thing. You can do inputs and outputs, and it is a function. I know that because the notation already tells me it's a function. And it's g versus x, doesn't matter. It's that set of parentheses and the x being on the right-hand side. Okay, well, what issues would we have with inputs when we have a rational function? So asking about the domain, where do I have issues? Well, I have issues when I have 0 in the denominator. We cannot divide by 0. It is undefined. So the question is what number and it can be more than one, gives 0 in the denominator. The numerator is not going to impact this. It's the denominator that's impacting things. So what we're going to do is we're going to come in and set x minus 4 not equal to 0. And we're going to say that x can't be 4. If I plug in a 4, I get 4 minus 4, which is 0. So what does that mean for my domain? Well, that means that on the number line, here is the 4. We can't use it. So it would be an open circle. We're going to go every number to the left and every number to the right. So its domain would be negative infinity to 4 with the parenthesis, because that's how we're going to exclude that value. And then we're going to go from 4 to infinity. And there's our domain. So again, we're looking at the number we cannot use. When we did the rational functions, when we did the radical functions, we looked at the numbers we could use. Here we're looking at the number we can't use. It's a slight difference in terms of what we're doing. Okay, what about the part B on that case? Part B states h of z is equal to 4 all over z squared plus 2z. So we recognize that this time the function is being written in terms of z, and z is the only variable we see on the right-hand side. And we're going to recognize that we've got a fraction. Z is on the bottom. We can't divide by 0. So we need to know what numbers would make this denominator 0. So I'm going to come in and take z squared plus 2z, set it not equal to 0. We're going to factor this. Let's go out z, that'll be z plus 2, not equal to 0. So I see that z can't be 0, which makes sense. If I plug in 0, this is 0 squared plus 2 times 0 is 0. And z can't be a negative 2. Negative 2 squared is 4, minus 2 times 2 is 4. So we get a 0. So these are the numbers we cannot use. Can't use a 0 and a negative 2. This time it's 2 sets, 2 numbers. That's okay. So I'm going to go to the number line to help me interpret what's going on. So here's the negative 2, here's the 0. We need open circles on both of them, but they're the only things we can't use. So we can use everything else. So that's what the picture would look like. So we're going to need an interval for each piece of this. So our domain would go from negative infinity to negative 2. That's this guy. From negative 2 to 0. That's the middle piece. And then we're also going to go from 0 to infinity. And there's a domain. Much more complicated, right? It's more complicated because we have that extra, because we have a quadratic or that extra variable in the denominator. What about case 3, the anything else category, my favorite category. So for that guy, case 3, other types. Case 3, anything else. So as examples, part A is f of x equals 2x minus 1. That's that linear function we keep coming back to. B is p of x equals x cubed. I'm going to throw in a c just because I need you to see it. Let's do s of x is equal to the cubed root of x plus 2. So it's an odd root, cubed root. Okay, well, because they don't have a radical, you don't have to worry about having a square root of negatives. Odd root, you can take the square root of a negative. They don't have any x in the denominator, so they basically have no restrictions. So the domain for all of these is going to be negative infinity. So there are no restrictions, and that's what we're recognizing. That's why it's my favorite category. Now, as we proceed through the course, once we get into the later chapter, we're going to add to this list of possible domain questions. We'll have other functions that do have restrictions, but for right now, the next 3 chapters, this is all we got, which is kind of nice. What happens if I classify one as 2 of these categories? So our next example, so example 4, asked us to find the domain of the following function. F of x is equal to the square root of x plus 3 all over x minus 2. So I have issues because I have a radical. I have another issue because I have x in the denominator. We'll separate those issues. So in terms of the numerator, the top, it's the square root of x plus 3. So I'm going to the radical. That's the numerator. So we're going to take that x plus 3. We're going to set it greater than or equal to 0. We know that x has to be greater than or equal to -3. So there's part of our problem. Okay, from the bottom, that's the x minus 2. That's the denominator. That can't be 0. So x cannot be a 2. And you don't necessarily even need to write this. Some of you will be able to look at this and see that's the number you have to avoid. So what we need to do is pull those 2 pieces of information together. In numerical order, here's the -3, here's the 2. So from the numerator, we know that we're going to start with a closed circle on the -3, but we have to avoid 2. So we need an open circle on the 2. And we're going to the right because we need greater than. There it is. So there's the picture of what's going on. That's the sets of numbers we can use. So to write the domain now, we're going to start with that -3. We're going to go to 2. We need a bracket on the -3 because we can use it. We're going to use a parenthesis on 2 because we cannot use that too. And then union from 2 to infinity. And there's our domain. And that's how you find the domain of the function.